Have you ever wanted to learn about how electrons were discovered? Probably not, but I don't care. You should want to know, and you will know when we are done with this video.
Hi, I'm Joseph John Thompson, but you guys can call me JJ. You guys have learned all about molecules and electrons in school, but I'm the one who actually discovered there was something smaller than that.
Wow! I didn't know we were having a special guest. This is awesome!
Story time!
Yay!
Once upon a time, lots of scientists used this thing called a cathode ray to study small particles. A cathode ray tube is basically a specially made glass tube with a cathode that has a negative charge at one end and an anode with a positive charge at the other end. These things can be made of different metals, and they create an electric charge that flows from one end to the other, and it makes it glow up. Super cool! The particles that flow from the cathode to the anode are called the cathode ray. So, like, everybody knows that a cathode ray has a negative charge. I mean, duh.
Duh!
But I really wanted to see if you could take the negative charge right out of the cathode ray.
Well, can you?
Not exactly. In my first experiment, I tried to use the magnet to separate the negative charge from the cathode ray, but it didn't work. That means the negative charge is part of the cathode ray.
So then what did you do?
Machines told me that the cathode ray had a negative charge, but the ray wouldn't bend towards the magnet like it was supposed to. I was so confused. Finally, I realized that these particles were probably using the air around them as a conductor, which was stopping them from being attracted to the magnet.
There's more? Then what happened?
So this time, I took all the air out of the cathode ray and tried again, and this time it worked. The cathode ray bent. This means that all the particles in the cathode ray are made up of negatively charged particles, but I didn't know what any of them were. Then I used all my special machines to figure out what the ratio was between the mass of this object and the charge. It was really, really small, almost 1 over 1,000. This means that either the particle was really, really small or it had a really big charge.
Oh my god, it was so great having you.
Thanks!
Hug! Okay.
Bitsy's on a break. Oh my god, it's Robert Milliken!
Hi.
It's so great to have you.
Yeah.
I'm famous. He is famous. Famous for finding the mass and charge of an electron using his oil drop experiments, that is.
Yeah.
Can you explain that to us?
I give oil droplets a negative charge and sprayed them between two electrically charged plates and recorded how the charge of these plates affected the droplet's rate of falling.
Whoa, tell me more!
I realized the charge of every droplet was a multiple of the same number, which allowed me to find the charge of a single electron.
Oh my god, that's amazing!
I then used Thomson's mass to charge ratio to find the mass of one electron.
He concluded that because a cathode ray has the same effect on all gases, electrons must be present in all gases.
I also concluded that because electrons have a negative charge, but the charge of an atom is neutral, there must be positively charged particles in the atom as well.
It was great having you. Bye! He also concluded that because the electrons contributed to so little of the total mass of the atom, there must be another part of the atom that made up the missing mass.
I'm William Thompson, but you can call me Lord Kelvin. I'm a simple man, and all I really need is pudding. Plum pudding. The nucleus is surrounded by a negatively charged field of electrons. If any of the electrons are displaced, they will move back to their original position. That's all for today.
Did somebody say pudding?
simple man, and all I really need is pudding. Plum pudding.